You know, for the longest time, we've thought of AI as something that just answers our questions. You type, it types back. But what if it could do more? What if it could actually do things for you? Well, that's exactly what's starting to happen. And the story of how AI learned to think before it acts, it changes pretty much everything.
Imagine an AI that doesn't just spit out one single confident answer. What if instead it kind of paused for a second, thought about a plan, took one small step, looked at the result, and then decided what to do next? That tiny little change? That's the difference between an AI that just talks and one that can actually solve problems out in the real world.
Okay, so here's what we're going to cover. First, we'll look at the old way AI worked, the confident guessing machine, and why it kept getting stuff wrong. Then, we'll uncover the missing piece that totally changed the game, a super simple three-step loop. We'll see it in action, kind of like a detective, and then we'll tie it all back to the AI agents you're probably hearing about everywhere today.
All right, so to really get why this is such a big deal, we got to go back a bit. Let's start with how these models used to work.
So, the early models. Think of the first versions of ChatGPT. They were incredible, right? It's like they'd read the entire internet, but they were trapped. They were like these brilliant librarians stuck in a soundproof room. All they could really do was predict the next best word in a sentence. They couldn't go search the web, they couldn't run a piece of code, they couldn't even check if what they were saying was, true. And that right there led to this huge problem. See, the AI could sound incredibly smart and convincing while being completely and totally wrong. Researchers have a name for this. They call it hallucination. It's not that the AI is lying on purpose. It's just generating text that looks right based on its training data, but it has zero connection to actual reality.
So this is really the core idea here, the big shift. We're moving away from an AI that just gives you one big take it or leave it answer to an AI that takes a bunch of small verifiable steps. It's really the difference between a confident guess and a careful, deliberative investigation.
Okay, so the researchers knew something was missing. They basically had two pieces of a puzzle. One piece let the AI think, and another piece let it act. The problem? They just couldn't get them to work together.
So the first piece was this really cool breakthrough called chain of thought. Basically, researchers figured out if you just prompted the AI to think step by step, it would create this kind of inner monologue. It could reason its way through really tough problems. But here's the thing. It was still stuck in that soundproof room. It was just talking to itself with no way to get any new information from the outside world.
All right, so the second piece of the puzzle was giving the AI tools, things like a calculator, or more importantly, a search engine. And suddenly it could do things. It could finally act in the world. But it was clumsy. It would just start doing things without a real plan, getting stuck or using the wrong tool because it couldn't really reason about the bigger picture.
So you see the problem, right? This was the missing link. You had an AI that could think but couldn't act, and an AI that could act but couldn't really think straight. The huge question was, how do you get it to do both at the same time?
And this is where it gets really, really interesting. The solution wasn't some bigger, more complicated AI. Nope, it was this incredibly simple, almost elegant little loop.
They called it REACT, which is just short for reason and act, and it works in this continuous three-step cycle. It's super simple. First, the AI has a thought. This is its internal monologue where it plans its next move. Second, it takes an action, like using a tool, let's say a search engine. And third, it makes an observation, which is just the result it got back from that tool. And then it just does it all over again. Thought, action, observation, over and over.
Now, I know that might sound a little abstract, so let's use an analogy that makes this whole thing crystal clear.
Think about a detective trying to solve a case. They don't just figure it all out in one big flash of insight, right? They follow a process. First, they think something out loud, like, that alibi doesn't quite add up. That's the thought. Then, they take an action based on that thought. Okay, I'm gonna go check the security footage. That's the action. Then they look at the result. Whoa, the suspect wasn't there at all. That's the observation. And that new clue, that observation, feeds right into their next thought, and the cycle just keeps going. That is exactly what this new kind of AI is doing.
Okay, let's look at a real-world example from the paper. They asked the AIs a tricky question about the old Apple remote. The reason-only AI? It just made up an answer. Total hallucination. The act-only AI just searched around randomly with no plan and eventually gave up. But the React model, it was different. It thinks, okay, first I need to search for what an Apple remote is. It does that, sees the result, and then thinks, all right, now that I know that, I need to search for the specific program it used to control, and so on, step by step until, boom, it finds the right answer.
So where did this whole idea come from? Well, this entire concept was laid out in this landmark paper from 2023. It's called REACT, Synergizing Reasoning and Acting in Language Models. And it came from a team of researchers at Princeton and Google. They were the ones who finally cracked the code and figured out how to get thinking and acting to work together.
So you might be wondering, why is this simple little loop such a massive deal? Well, because it makes the AI unbelievably more reliable and way more capable.
And the impact here is just wow. In one of their tests, the researchers found the old reason-only method failed because of hallucinations 56% of the time. It was just making stuff up more than half the time. But the REACT method, because it was forced to constantly check its work against the real world, it had a hallucination failure rate of 0. That's not a typo, 0. That is just a mind-blowing improvement.
And it's not just about being more truthful. It's about being more capable, too. On a really complex task inside a simulated environment, the REACT model was 34 percentage points more successful than older methods that were specifically designed for that one task. So this general purpose loop was actually beating the specialists at their own game.
And this isn't just some dusty idea in a research paper. No way. This thought-action loop is the fundamental engine that's driving all the AI tools you're hearing about today. Things like LangChain, AutoGPT, even Perplexity AI. All of these agentic workflows are built on this core principle of an AI that can reason, then act, then observe.
Okay, but it's really important to be clear about what this is and what it isn't.
Yeah, we have to remember this is not a conscious being. The AI isn't thinking the way a person thinks. It's running a very, very sophisticated pattern matching process. It can still get confused, it can get stuck in a loop repeating the same action, or it can just make a simple reasoning mistake. It's an incredibly powerful tool, for sure, but it is not a perfect mind.
And that really gets to the heart of it. The goal kind of shifted. It became less about trying to build a perfect artificial human mind and more about building a tool that can act for us, reliably and transparently. A tool where we can actually follow its work step by step. We can literally read its thoughts and see how it got to an answer.
So, we've gone from an AI that just talks to an AI that actually acts. That is a fundamental ground-level shift, and it leaves us with this one huge question. As these AI agents get more and more capable, what are we going to ask them to do next?